Welcome, ladies and gentlemen, to the most exciting show on Earth. Today, we will be talking about atoms. The atom is the basic defining structure of an element, and everything is made of elements, so they're pretty important. An atom is made up of protons, neutrons, and electrons. So what does each part of the atom mean? The nucleus is the center of the atom. It is dense and it contains the protons and the neutrons. The mass of the nucleus and the number of protons it has influences its properties. It is positively charged because of protons. For instance, when the nucleus is larger, thus having more protons, it has a greater positive charge, meaning that it will have a greater effective charge and a stronger pull on electrons. The protons are the positively charged parts of the nucleus. They are the things that determine the classification of the atom as an element. Atoms with the same number of protons are the same element. The neutrons contribute along with protons to the atomic mass. They have no charge. Depending on what number of neutrons there are different isotopes of elements which have different atomic masses. Neutrons do not contribute to any attraction or repulsion. Electrons are the negative particles that orbit the atom in electron clouds. Their exact location at a certain time is impossible to know, but they can be predicted to be in certain orbitals based on their energy. They move quickly and a lot, and they contribute greatly to the chemical properties of an element. Atoms can bond with others based on the number of electrons, oh, there's a bond, in the outer or valence shell. Electrons can be transferred or shared, sometimes equally, sometimes not, to achieve stable configurations. This is why certain atoms have certain chemical properties. Now let's talk phases. We've got solid, liquid, and gas. The atoms of an element determine what phase it's in. If the atoms are rigidly bonded in a structure with little movement, then the element will likely be a solid. If they are bonded, but by more intermolecular forces and thus looser to move around, the element could be in liquid form. And, of course, if the atoms are moving around quickly enough, with enough kinetic energy to overcome any intermolecular forces, then it is likely going to be a gas. Other factors like pressure and temperature also contribute, but in the end, those factors simply change the way the atoms are moving, not its state. Well, let's talk about an element. Here's a good one, for example: helium. Helium's atomic number is 2, and its atomic mass is about 4, so it only contains 2 protons, 2 electrons, and, in its most common isotope, 4 neutrons. A difficult concept, I know, but we ask that you at least try to wrap your head around it. Helium has a full valence shell, making it a noble gas. Noble gases are unreactive. They don't share electrons with other elements. That means, for example, if you've ever written this formula, then you've been wrong at least once in your life. Well, probably more. You almost never see noble gases like helium in chemical equations. Indeed, helium is the second least reactive noble gas, behind neon. It doesn't react or burn or do any of the cool things that non-noble gases do all the time. Helium's nucleus is also tiny, so it's lighter than air. That's why helium balloons float into the sky and make you so gosh darn happy. Hey, let's talk about carbon, one of my favorite elements. Carbon is one of the most useful and abundant elements in the universe. It is a non-metal that usually has 6 protons, electrons, and neutrons. Carbon naturally comes in 3 different forms: amorphous, graphite, and diamond. Shiny, isn't it? These 3 forms are only different in their crystal structures, but it gives them drastically different properties. Graphite is one of the softest materials known. It's common for being used in pencils, known as lead. Oh, it broke! Graphite is soft because its carbon atoms are bonded in hexagonal sheets which are in layers. These layers are connected by van der Waals forces instead of being covalently bonded. On the other hand, diamond is one of the hardest substances in the world. Oh, isn't that just cute? Alright kids, let's talk about one of the coolest elements ever. Let's see what it is. Gallium! Oh, but narrator, you ask, what's so cool about gallium? Well, I'm glad you asked. This is what's so cool. Gallium has a very fun property of having a melting point around 87 degrees Fahrenheit. That means it's a solid at room temperature, but if you hold it in your hand, or your mouth for long enough, it becomes a liquid. Isn't that something? Now, why, you ask, does gallium do this? Well, it's actually not that easy of an answer. Gallium has 31 protons, neutrons, and electrons in its ground state, but that doesn't have much to do with it. What actually causes gallium's melting point is the weak bond that it forms between other gallium atoms when it's in a sea of electrons, which is what occurs when you have lots of atoms put together. These weak bonds allow the gallium atoms to break apart easily from their solid phase and become a liquid. Righteous! Isn't that cool? Geez, that is so awesome. Well, just don't try to drink it. Thanks, DYB's hand. So there you have it, a brief summary of atoms and what they are. They make up everything: the air we breathe, the rivers we swim in, the trees we climb, the food we eat, and everything else. Don't take atoms for granted, they're pretty cool. Thank you for watching, and have a lovely, lovely day.